Yes, my name is Lange-Küttner and I'm with the university since 1999 as a senior lecturer. Really is my student since a while, and so this is only part of her master's. She also the main part is the memory for objects in children with ADHD and ASD. And I'll explain in these slides what that means, what is ASD and what is ADHD. I'm going to say something about the Gestalt principles of grouping, about spatial array development, fine motor skills and drawing development, about the common region test, about children with ADHD and ASD, and the role of fine motor skills in this particular test. So what are Gestalt principles? So Gestalt principles describe how we are mentally grouping stimuli together. Now, if you have a look at the picture, the question is, what is the object in this spatial field? And in visual perception, this is this for me to expand something? All right, yes, I can do that. Yeah, now this is very big. Okay.
It's for the audience.
Pardon?
It's for the audience to expand, everybody individually.
Oh, I see. Yes, I've done this now on my computer as well, so it's much bigger. So what happens is that we have a retinal image in our eye, and this retinal image gets stimulation, which is not a clear picture. It gets projected via various visual pathways that we teach in psychology to the back of the brain where the visual cortex is, and from there on the brain works out what an object is in this kind of messy input. So these Gestalt principles of grouping were launched on a very speculative basis at the beginning of the last century, but it turned out that in terms of neuroscience, it was all true, what other scientists doubted for a long time. So in order to create a complete percept, our mind fills in the missing parts of our fragmented visual input. I also do some research on fragmented language input. So this is the fragmented visual input, and in the mind we draw a contour around stimuli that we think belong together, and we draw a contour. So all these dots inside the contour belong together because what we've got is a meaningful shape. We can also have an alternative strategy where we color in a shape so as to provide a surface. So this is the coloring in, and you can see the gray shade, and this is like an area where these dots belong together because they are in the same area. Now, what children do initially is when they are drawing, they are not drawing such arrays. They are drawing this space system. Let me just get the pointer. So they are drawing this space system 1, and we call that empty space because they draw only objects. That doesn't mean that they have no concept of space, but the concept is one object, one place. So they can still say what is left and right and up and down, but they would only draw the objects themselves. Then the next stage would be the space system 2, and there you have ground lines or stripes for heaven and earth. So you sometimes have the ground line, and then you have the sky, and there's sunshine in the corner. So this is a very typical space system 2. Then we have the next stage, and that's quite an important one, where they are drawing areas. So this is the first creation of the spatial field, which is similar to what you've seen on the slides before. And then the next are really not qualitatively that much different. They just become aware that you can have a certain viewpoint. So this would be the introduction of this perspective, but you still have the area, and then that's the same for space system 5, where they become aware that space is unlimited. So here they are drawing boundaries, and then this is a concept that is becoming a bit more weakened because the boundaries are still there, but they point into unlimited space. So one of my questions was, what happens to objects in the field? So maps are very good examples. So here you have the maps of London, and you can see it's full of landmarks, full of objects. So these are important, and then they become drawn on this map as individual landmarks. But you can see that then with time, these landmarks become not necessary, because the axis system, the spatial axis system, becomes very important. The streets are named and the houses are numbered, so it becomes much more similar to mathematical space. And you can see here that here the landmarks become very small, sometimes just icons. Here are the underground icons and some sites. And here they are areas. So here's the British Library. And you can see that the figures become small or even dissolve in favor of these areas. This is not a self-understanding development, because there are parts of the Earth of our world, where this spatial axis system is not so systematic. So you have to draw your address because there are no house numbers. But grids are very useful in spatial arrays. So we have grids are common in math paper, in maps, in calendars. And now the question for a developmental psychologist is, how do children draw these grids? And the children draw these grids not as a grid, but they draw them as individual places. So you have one place and another place, and this all adds up to some sort of aggregate space rather than a spatial axis space. So this is now the development of what we call spatial binding in the common region test. Oh, hold on, this was one too far. Okay, so here this is the common region test. And Wertheimer was a Gestalt psychologist. They all emigrated to the States. This is Stephen Palmer. This array is taken from his paper. He wrote a huge textbook on vision science. So what you can see here is that this is an array where the dots are grouped according to Gestalt principles. So the first row is where all the dots are equidistant, that is, they have the same distance and they are all the same. In the second row, they're also the same, but one of the Gestalt principles is proximity. That is, two dots are closer to one another than, say, these two dots. Okay? And the third row is the same as the first row. It's just that the appearance varies. So these are of a different color than the second one. So what do these, how can you draw a circle around those objects which you think belong together? And in this task, you can basically see whether these visual Gestalt principles are being noticed or not. So here we have the object place binding, and you can see that each object is allocated a place. And that's a fairly systematic strategy. Then we have a second strategy that is unsystematic binding, and you can see that sometimes they are allocated a place, sometimes they are allocated a region, sometimes it matches, sometimes it doesn't. So the basic feature of this way is unsystematic binding. And then the third one, and this is what all adults are doing, is they are drawing a region around all the dots in A. They are drawing a region around those dots which are close together, and they are drawing regions around those dots which have the same appearance. Now, there are age trends. This is from a study where we had a sample which showed a very typical development. So the 5-year-olds are drawing these individual places, and that's going down with age. These are the black bars. The after 6 years, the unsystematic coding starts, and this is the common region starts, and this is going up and up and up until all adults are doing it. And then we have the unsystematic binding, and this is where you could say there's a certain degree of confusion, and it is what developmental psychologists call a transitional phenomenon. So the binding goes up and then it goes down again. So this is a transitional phenomenon while the individual binding goes down and the common region binding goes up. So now I'm going to show you two slides which make a little bit of a difference whether in the way unsystematic coding is carried out by the children. So you have here the unsystematic coding, which is still dominated by object place binding. So we call that unsystematic coding type 1, and it is in a way under-inclusive because the dots are still allocated one place and they do not include other dots, but sometimes they do. And this is why it's unsystematic. So sometimes they do, sometimes they don't. So here, this is an example of a girl, and this is an example of a boy. We have also an unsystematic binding type 2, and this is over-inclusive. So the Gestalt principles are not or only partly recognized, and all the dots go into one area. So here you can see examples where common region grouping is already achieved, but it's devised in an unsystematic fashion. So we call that unsystematic binding because not all the Gestalt principles are recognized. Okay, so now we come to fine motor skills in drawing. So here you can see the outcome variable. This is a study of Tomela from 2002, and they had several tasks: memory, picture naming, figure finding, block construction. Don McRae mentioned blocks. Popple-Reuter's task is a figure finding task in visual noise and mental rotation. And here are the fine motor skills. Now, this is the model for drawing between 2 and 7 years. And what you can see is in this age span, you have age as a clear predictor for drawing, block construction as well, and mental rotation. Now, if we go a little bit further in age and we have 8 to 11-year-olds, this picture has changed. And you still have block construction and mental construction as a predictor for drawing. But now there's a new kid in town, and that's fine motor skills. So you have fine motor skills instead of age as a direct predictor in drawing. Okay. Now there's another aspect which I'd like to mention, and this is drawing small. So you saw already on the London maps that the landmarks started disappearing, and the same is true in children's drawing. So with the onset of the spatial system, children start to minimize the size of the figures. So the empty space that was stage 1 is competitive space. So the more objects there are, the smaller they have to be because they take away space from each other. But with the onset of the spatial access system, and this here would be stage 3 because you've got a spatial field, so the more the children now see that this is an area. So the more advanced the spatial system, the greater are the spatial constraints for the figures and the smaller are the figures. So here are some examples from a study where you can see that some of these children adapt, so they draw very, very small. They also become more flexible, so they can draw small and they can draw large. This one is drawing small and keeps the size in the perspective one, and this one shrinks the figures but still draws like a 7-year-old, although the children are already of an advanced age. So we are always working with averages. This is an explicit study on fine motor skills parameter development. So these are the Bender Gestalt cards, and I'll come back to that. That's why I included it in the introduction. And you can see these are 2 cards where there are loops, and then there are drawn out loops. And with age, so when they get into school, the interesting thing is they start drawing slower. So this becomes slower, and this is even slower. And why is that? Because the onset of handwriting. Then they learn to draw open forms. So these are all closed forms, but these are open forms, and they need more time to draw open forms than closed forms. And why is that? Because they need to inhibit their fine motor skills. And then we have the issue of pressure, and so we have here these zigzags and then again the loops, and when you compare them, the zigzags, although you would think they are angular and they are more geometrical, and this is why they are more difficult, in terms of fine motor skills, they're actually easier for the children. So they use more pressure, but they use less time when they're drawing zigzags compared to these loops. And what we find then is that drawings predicts handwriting quality. So this was a study of a group of Malaysian engineers who picked up on this study and from me in 1998 and worked together to develop an algorithm that would automatically analyze these figures. And we published that together in 2015. So here's another the last slide on fine motor skills. So here the introduction was, please draw half a figure. And you can see at 5 years they don't. They have this block building where they use what we call conceptual primitives, and they are mostly circles with extensions. Then they start to draw real shapes, which comes along with the onset of the common region. But you can still see that they have no idea of a spatial access system. But at 11, you can see that there's a spatial access system through the figure, and they can inhibit the drawing whole forms. And this is a vertical axis, and this is a horizontal axis. So now I'm coming to another aspect of the study, and I'll give you a very short introduction on what is ADHD. So ADHD means attention deficit hyperactivity disorder. And it's often associated with impulsivity in behavior and decision making. So impulsive or explosive behavior is frequently associated with educational underachievement, antisocial behavior, underperformance at work, and poor psychosocial adjustment. So what is ADHD? It is a chronic neurodevelopmental disorder. It's highly heritable. There are impairments in attention, hyperactivity, and impulsivity. It affects about 3 to 7% of the population, and there are more males than females. So in community samples, it's about 3 to 1, 3 boys to 1 girl. And in referred samples, that means you're being referred to an examination in the Child and Family Services, the ratio is even more pronounced, 9 to 1. And it is a lifelong persistent disorder which can, in adolescent, result in teenage pregnancy, multiple car accidents, and personality disorders. So they are further classified in hyperactive, impulsive. Some are just inattentive, and some have the combined type. The inattention type is more difficult to detect because you need to find when somebody is not paying attention. So that's not a non-behavior, which is more difficult to detect. What about drawing? Children with ADHD were found to be less skilled in drawing the hands of a clock. They show deficits in design fluency, spatial organization, visual search, and visual memory. And interestingly, we have more research now on motor skills and cognition and training of motor skills and manual dexterity. That means you're right-handed or left-handed, appears to be successfully mediate cognitive function in children with ADHD. Now, what is ASD? ASD is the abbreviation for autism, and autism was first described by Kochhar and by Asperger in the 40s. It's also a pervasive neurodevelopmental disorder, but the impairments are very different. It is an impairment in imagination, communication, and social interaction. That's Lorna Wing's triad. The incidence or prevalence is 1.5%, and it's going up because in 1978 the prevalence was only 0.04, and it has been included in the NICE guidelines, which is the guideline for the Child and Family Services. It's also more common in males, and in low functioning children with autism, the ratio is 4 to 1, but if they are more intelligent, we call it high functioning, there are even more males, so it's 6 to 1. So it's basically sociability which is impaired. So it's difficulty developing peer relationships, lack of social emotional reciprocity, delay or lack of speech, poor use of language, lack of sustaining a conversation, lack of make-believe play. Then the imagination, and this is one of the most robust symptoms, that there are restricted repetitive patterns of behavior which sometimes help them to become quite adept in various domains, cognitive domains. They're somehow genius-like people with autism as well, and you'll see an example on the next slides. So they follow very rigid rules. They get upset when these rules are violated. They have interest in details with object parts, and they show suspicious motor activities like hand flapping and spinning. That is already, we found in psychology that this is already very observable in very young infants from 6 months to 10 years. So they do not engage in joint attention and gaze following. In social referencing, they don't understand teasing, so there's no humor there. They are not good in shared play. They don't understand pretense, deception, and false belief. And mentalizing is a more advanced way of understanding somebody else. So this can be diagnosed fairly early. And in drawing, this was a revolutionary book in 1977, published by Lorna Self, and this this drawing was done by Nadia. We hopefully didn't sell the book in our library. We do have an exemplar. This drawing was made by a girl who was 3.5 years of age at the time. So they're basically skipping this building block stage, and they are drawing visually realistically like camera, basically, from the very beginning of their life. So also in identifying embedded figures, the one with the Dalmatian in the beginning is superior in individuals with autism. But this ability disappears when they start talking. So there seems to be some sort of trade-off between language and this more right brain activity. So now I'm coming to the common region study. It is in Press with Motor Development and Learning and will appear in December 2020. So what were our hypotheses what was the hypothesis of myself and Ridi? So we would predict that children with ASD would show persistent object and place binding in the CRT because they attend more to local details than global processing, and they would draw rather smaller than larger. They would attend to rather smaller than larger categories. We didn't really have a hypothesis for children with ADHD, but we thought in terms of the common region test, but we thought that the Bender-Gestalt test would reveal motor deficits, especially in children with ADHD. So these data have all been collected by Ridi. She collected the data at local schools in Hounslow in London, and there are special schools in Hounslow where we had the special needs groups. So the needs were so severe that they were referred to special schools like the children with ASD and the children with ADHD. And then what we do in psychology is we match those groups with children who are either of the same age, so CA means chronological age, or we match them with children who have the same mental age. That is, they have the same verbal intelligence. So you can match them on non-verbal or on verbal intelligence. We selected them according to verbal intelligence. This is the result, and this is a bit more detail. If you have questions about this slide, we can answer that later on. This is just where they differed and where they didn't. You can see that the verbal intelligence, the BPVS, is the British Picture Vocabulary Scale. So this is always 1, and that means they are identical. Okay, and now we come to the results. So what you can see is that in this sample, these are now just the control groups. So we call them control groups here because they are the children which were matched with the children with special needs. And what you can see is that in the typically developing sample, the individual coding or the object place binding goes down. So they stop drawing places and they start drawing regions and areas. So this is how it should be, but then what we found as well was in this British sample, previous sample was a continental one, that we have 30 to 40% of unsystematic region allocation. And this is a constant percentage which goes down a little bit from 40 to 30%, but it's not a transitional pattern. It's a substantial percentage of the typically developing children who show unsystematic drawings. Now we have a look at the children with ASD. How do they draw in the in the common region test, and we were really a bit shocked when we saw that for the first time. So you can see that the children with autistic, in the autistic spectrum, showed unsystematic coding in more than 70% of the cases. So this is more than double than in the in typically developing children. And if we look at the children with ADHD, you see the same thing. So also these children with ADHD show mainly unsystematic coding. So here you can see in this group here, it was not the case, and there is this common region area coding that you would expect. In the chronological age group, you still have a bit of unsystematic coding, but not as much. So the what needs to be said as well, that's not visible in the graphic, is that the children with ASD showed mainly type 1 automatic coding. That is, they had, as predicted, a lot of object place binding and very little of object region binding. So 13 out of 14, or 92.9%, were still drawing object place binding. If you go to the ADHD children, they showed mainly type 2 unsystematic binding. So the ADHD children showed 70.1, but this was also high in the typically developing children. So this was a dominance of over-inclusive spatial binding strategies. Then we had a look at the fine motor skills, and the Bender test consists of Bender perception, Bender motor, Bender copying, and Bender recall tests, recall scores. And the typically developing children, all these 4 Bender scores, remember the slide I showed before with the pressure and the speed of fine motor skills, all this correlated with the common region test significantly. So all these values say that about 1/3 of what they do in fine motor skills explains what happens in the common region test. So 1/3 of their abilities contributes to the common region test of their fine motor skills. So 30% of the differences between the children in the typically developing sample is explained by fine motor skills. In the children with on the autistic spectrum, there were no significant correlations. And then we looked at the children with ADHD. This was the same, but when we looked at the different subtests, we found significant correlations with the perception, that is the perception of these Gestalt principles, and we found a very high correlation with Bender motor scores. That is, more than 70% of the drawing in the common region test was explained by their fine motor skills. So we had a look why this would be the case. And now these are 3 plots. So we have the first plot. These are the Bender motor scores in children with autism. So these are frequencies. See here the count. And now we make a difference between unsystematic coding type 1 with mainly object place binding and unsystematic coding type 2 with mainly common region binding. So the first plot is with the children with autism. The second plot is attention deficit hyperactivity. And the third plot is just the typically developing children. And these are just the children who show unsystematic coding, also in the typically developing sample, because remember there was quite a substantial proportion of children in the mainstream schools who showed over-inclusive binding. And what you can see is that this task was dependent on the motor skills. So these are the Bender scores. They go from 1 to 9. These go from 0 to 11, so the scale is a bit different. And these go from 7 to 12. So what you can see here is that the children with autism had the lowest fine motor skills, and they used mainly object place binding, except for one child. Then if you look at the children with ADHD, you can see that there's some sort of cutoff point or threshold where they start drawing unsystematic, but the mature common region strategy with more over-inclusive patterns and no object place binding. So there's a cutoff point with a score of 8. So over 8, they use type 2, they show type 2, and under 8, they show type 1. Then if you look at the typically developing children, this percentage of 1/3, you can see that the values are normally distributed. That's this. But the score only starts at 7, so it basically starts here at 7. And you can see that they mainly show unsystematic coding type 2, the over-inclusive, but there's also a bit of under-inclusive binding. So you can see that the fine motor skills are very important, are a very important predictor in children with special needs, both in children on the autistic spectrum and in children with attention deficit hyperactivity disorder. So the summary is, as expected, object place binding decreased and object region binding increased in typically developing children. Both children with ASD and ADHD showed a lot of unsystematic binding, nearly only unsystematic binding, and the children with ASD showed more object place binding, which we called under-inclusivity, because the dots are not bound into a common area, while children with ADHD ignored Gestalt principles and showed more over-inclusivity when compared to their mental age control. So unsystematic and the control for fine motor skills showed that the unsystematic spatial binding has to do with a lack of well-developed fine motor skills, and remember that these are mainly boys. So the conclusion then is that spatial categorization and spatial grouping, which we call binding, in children was always seen as a mental, conceptual, cognitive process, like an attitude, but the current study with children with special needs shows for the first time that fine motor skills play a role in unsystematic spatial binding in the visual domain, and it confirms current efforts in labs worldwide that nonverbal IQ in children with special needs has a basis in motor learning. So I think I'm well in time with 36 minutes, exactly the time I needed yesterday during my rehearsal for the presentation. So I think I'll be fine. So in terms of timing, thank you for your attention and have a great research conference at the London Met University.
Thank you so much.